So let's look at the third page, so page 23. Okay, we're still working with doing the machinist problems. So in this one, he's trying to cut a keyway, which is this little cutout right here, so that something can go through this area of this circle. Or so things can link together right there or something. There's a reason for this notch to be cut out in whatever project. So in order to make them all the same, we've got to know all the dimensions of things. So find the width of the keyway using the formula x equals d minus 2z. Okay, d is all the way from top to bottom, so that's the diameter, okay, of the circle if there was no cutout right there. Okay, so that's our x that it's looking for.
So does z equals the radius?
The z, no, is actually from the side. Oh, the d, sorry, is the diameter. Yeah, the x is this little bitty notch right here.
No, I'm saying ZD, like the radius.
Z is the radius minus half of the notch because the notch is centered, right?
Mm-hmm.
Well, let me look at that. Because to me, this doesn't look like the Z goes all the way to the middle, right?
No.
It goes to right here from what I'm looking at the diagram. So, oh yeah, so that's what x is. We're trying to solve for x. We're not trying to solve for d. So we know what d is. D is all the way across. And two z's. Z is from the outside to where that notch begins. And because it would have to be on both sides, right? Right here, there would have to be a z on both sides. So that's why we take it away. We take two of them. So if the diameter of this circle, oh, it tells us right here on our diagram, is 3.5, and our z or does it give me my measure of z?
What could be the measure of Z?
The
1.625.
I know. I mean, it says it right here, but where does it say it on my diagram?
Up there. It don't.
It doesn't. That's what I was saying. So they give me a number here that it doesn't actually give me over here on the diagram.
Makes sense.
So, I mean, it gives us the number right here working it out, but it doesn't have it on the diagram anywhere, which is where I was looking for it at. So this is 1.625 is, I believe, 7/8, but we'll just leave 625. Not 7/8, 5/8. 1 and 5/8 inches. But yeah, they don't have that measure anywhere except for it's in the example without actually giving it to us. So anyway, so using their number that they give us here, we know that z is 1.625, and we have two of those that we have to take away from the 3.5. So two of those is 3.25. So 5.5 minus 3.25 left 1/4 inch. And then we know that since X is 1/4 inch deep, because it tells us right here, okay, that from where the edge would be to right here is 1/4 inch. Then 3.5 minus 1/4 inch means that my length of Y, so from this edge all the way down to the side, is 3.25. So hopefully they don't do that to you again and they give you all the measurements you need, because they didn't in this example problem. Let me know if there's a problem with another problem, how it's written. So you're going to refer back to this diagram for all of these, for 1 and 2. For this example down here at the bottom, okay, we're solving for the diameter if we know the area. Okay, so we know the area of this circle, which is 28.86 inches squared. Okay, and I have to undo my squaring. Okay, anytime you're going from something squared or an area of something to a linear measurement, we have to undo squaring, and that's where the square root comes in. Okay. So we're going to take the area and divide it by pi, and then take the square root. Because if you remember, our area of a circle is pi r squared, right? So in order to undo that, because it's not pi diameter squared, is it?
You want that as a fraction? Remember what?
No, they can be as a decimal. I don't have any answers of this one put in GoFormative yet. I only did the first 2 pages. So
You just divide the x by the area by pi, and then do the 2 square root thing. 2 square root area divided by pi.
So yeah, and it's 2 because you would get the radius. That right there only gives you the radius.
Yeah.
So to get the diameter, you have to multiply by 2. So that's why the 2's there in front. And don't leave anything in radicals. Go ahead and put it as a decimal answer. And then on the back side, there's one more example, and it's another drawing that you have to use the data from the drawing that it's given to figure out the taper of a punch. Okay, how much you need to taper it per inch. Okay, that's what TPI stands for, taper per inch. So I'm not going to work this one out for you because it looks like you're working on the other ones. So if you decide you need help when it comes to these two, come see me and we'll talk about how this worked. What?
You want it as a mixed number?
Not a mixed number, as a decimal.
You just want the whole thing.
You can put all of them as a decimal
I'm
answers.
just going to put the whole thing in.
That's fine.
Mr.
So, yes. Okay. Let me stop this video.